All right, y'all, today we'll be learning about solving and simplifying rationals. We're going to do two topics in one today, so get ready. Solving and simplifying rationals. All right, let's start with simplifying rational expressions. So go ahead and write that down, simplify rational expressions. We're going to get some steps in our notes, and we're starting with this example or warm up. We're only going to do one of these, so make sure that you write this example down. We have 4 over, and then we have 3/4 minus 3/2. 4 over 3/4 minus 3/2, or 4 over 3 over 4 minus 3 over 2. Okay, so obviously this is a complex looking fraction, and that's why we're learning to simplify it. So the first step that we're going to write down, is we want, so 1, we want a single fraction over a single fraction over a single fraction. So single fraction. So what we want is something that looks like this. Fraction over fraction. All right, so that's what we want to get to. Right now, we have 4 over 2 fractions. So really quick, if we were going to write 4 as a fraction, what fraction could we write 4 as? We can write 4 as 4 over 1. So that's a fraction. And then we have that over. We have 2 fractions though, 3/4 minus 3/2. We want 1 fraction over 1 fraction. So the first thing that we're going to do is we're going to take care of these 2 fractions. We're going to combine them. How do we subtract fractions? What's the first thing we need to do before we can subtract fractions? We need to get a common denominator. So let's make sure that we get a common denominator. I'm going to go with the least common multiple 4 in both of these denominators. So what do I need to multiply this fraction, the second fraction, by? I need to multiply the denominator by 2 to get to 4. And whatever I do to the denominator, I have to do to the numerator. So let me go ahead and write this next step down here. We have 4 over 1. That's our top fraction, over, and then we have 3/4, 3 over 4 minus, and then if I do, let me go ahead and do that up here, 3 times 2, you multiply across. 3 times 2 is 6, over 2 times 2 is 4. So down here, I'm going to put 3/4 over 6/4. Now, we still don't have 1 fraction over 1 fraction. We still need to get to that. So let's go ahead and simplify that even more. We have 4 over 1 over, over, and then 3/4 minus 6/4. Well, what you do now is you subtract the tops. 3 minus 6. Subtract your numerators. 3 minus 6 is -3. So we have -3 over 4. Okay, cool. And now that we have a fraction over a fraction, do you see here how on top we have one fraction, 4 over 1, and then on bottom we have another fraction, -3 over 4. We're ready to go for next steps. So what's our next step? Step 2 is going to be, 2 is to, once you get a fraction by a fraction, you multiply the outer numbers and put them in the numerator. So let's write this down. Sorry, I'm hesitating, y'all, because I know it's going to be a lot of information, but let's write this down and then I'll show you. So write down step 2, multiply the outer numbers, the outside numbers, and put them in the numerator. In the numerator. And then multiply the inside numbers and put them in the denominator. Okay, so we are going to multiply the outside numbers. And actually, let me write like what I call this trick. So I call this trick outer over inner. So write this down, outer over inner, because we will probably use this all year. And this is a really important skill to know for SAT, outer over inner. And then let's actually like draw what it's going to look like. It's going to look like this. Outer over, like divided by inner. And that's going to be the outsides divided by the insides. Okay, so now that we see we have all this written down, let's actually do it. So multiply the outside numbers. Outside, by outside, I mean the numbers on the very furthest outside. So 4 and 4, we're going to multiply those. So let's go ahead and multiply those. These are the outers. We have 4 times 4. And then put them over the insides multiplied. So let's do the insides multiplied. The 1 and the negative 3. The inner is 1 times negative 3. So outer over inner equals 4 times 4 over 1 times negative 3. All right, and now we just have to simplify. So outer over inner equals 4 times 4 is 16. 1 times negative 3 is negative 3. All right, and that is it. Outer over inner. And we check, can we simplify our fraction anymore? 16 divided by negative 3. No, we cannot. Just as a heads up, y'all, this can also be written as, you could take this negative and put it out front. So we could also write it as negative 16 divided by 3. Or you could see this fraction written as negative 16 over 3. So basically, moral of the story, your negative can be in the denominator, it can be out in front, or it could be in the numerator. It's the same thing. Okay, so the trick, if you have a fraction over a fraction, you can multiply the outsides, put them on top, and then you can multiply the insides, put them on bottom. That is your simplified fraction, outer over inner. Okay, let's move on to the next topic for today. So our next topic is solving rational equations. So go ahead and get this in your notebook. This title, Solving Rational Equations, and we are going to do 2 examples for this one with steps. Okay, so write your example down. Get ready to write steps. This is our first example. 6 over 2x equals 20 minus 7x divided by 4x. And our first step is going to be similar to the last problem. We want to get one fraction equals one fraction. So we want fraction equals fraction, right? Like we just want one fraction on both sides of the equal side. So how can we do that? Well, we already have that here. So there will be more complicated problems where you don't always have that, but check it out. On the left, we have one fraction, right? Equals one fraction. Okay, so when you get that, this is when you're allowed to use this trick. And now we are going to say, once you get one fraction equals to one fraction, you're going to cross multiply. Cross multiply, which means we're going to kind of draw, there's like an equal sign, and you're going to multiply across like this. And let me show you. So we are starting with this example. You're going to draw in your example arrows through your equal sign that are kind of pointing at opposites. So the numerator and the denominator on the opposite side of the equal sign. And then we're going to cross again and point at the denominator and then the numerator. Cool? Those things that are like diagonal from each other, we are going to multiply together. So let's go ahead and do that. When we cross through, we're not canceling out the equal sign. We're saying we want to multiply those things. So we're going to do 6 times 4x And then make sure you bring down your equal sign. It did not disappear. 6 times 4x equals 2x times, and anytime you have multiple pieces, multiple terms, 20 minus 7x, that's 2 pieces. We're going to put both pieces in parentheses. If you have multiple pieces in a numerator, denominator, put them in parentheses together. Okay, so multiple pieces separated by addition or subtraction. This one was separated by multiplication. That's why it was allowed to stay. You know, like not in a parentheses. Okay, so now that we have cross multiplied, this trick saves us. When we have a fraction equal to a fraction, this trick saves us because it gets rid of the fractions, the scary things, and turns it into multiplication. Now we can solve. We can simplify. 3, solve / simplify. So let's go ahead and do that. What is 6 times 4? That would be 24x equals, let's distribute the 2x. So we get 40x minus 14x squared. Okay, and then here's a tricky thing, y'all, that we need to know. We need to know this. Anytime you have x squared, what should you have one side equal? What should you set one side equal to? You have x squared. What do you set one side equal to? 0. Y'all, we need to get one side of the equation equal to 0. So what I'm going to do is I'm going to move both of these pieces to the left side by doing inverse operations. Why do we need to get equal to 0? Because y'all, x squared is a quadratic. In quadratics, we set equal to 0 to solve, and then we factor to solve quadratic. So we are going to do minus 40x plus 14x squared on both sides. And let's write it in standard form, this quadratic. So we're going to have the x squared term come first, 14x squared. The x term comes second, minus 40x, and then plus 24x. Actually, we could, it doesn't matter because those are both x terms, right? So plus 24x could come first, minus 40x. It doesn't matter what order those are in. Equals 0. Okay, good. We have one side equal to 0. So we're ready, we're almost ready to factor. We can simplify the left-hand side. What can we do here? 24x minus 40x. 24x minus 40x. That would give us negative 16x. Okay, so let me go ahead and write that down. We have 14x squared minus 16x equals 0. Sweet, we're ready to factor now. So what kind of factoring can I do on this left-hand side? I hope that you said GCF. Both of these numbers can be divided by 2, and both of these terms can be divided by 2, and they both have an x. So we get 7x minus, and then we have 8 equals 0. Cool. And the last thing we need to do is solve. So what does x equal? For this x out in front, what does x always equal? 0. And for this factor, we get x equals 8 over 7. Awesome. We are done. We solved. Do you see how the cross multiply, the second trick that we did, cross multiplying, that's the one we did in purple, that saves us. It helps us not have to deal with the scary looking fractions. Okay, now let's do this example. We're going to follow the same steps. So write down the example very quickly. We have 3 divided by x plus 3 times x minus 2 equals 3 divided by x minus 2. Let's check. Do we have the first step taken care of? Do we have a fraction equal to a fraction? Yes, we do. So now that we know we have a fraction equal to a fraction, we can move to step 2, cross multiply. So here we go. I'm going to draw arrows across that mean, okay, I'm going to multiply the 3 times the x minus 2, just like I did the 6 times the 4x. And then I'm going to do another cross through the equal sign saying, oh, now I'm going to multiply this denominator, x plus 3, x minus 2, times this 3. And remember to bring your equal sign down. Okay, here we go. We have 3 x minus 2 I'm putting in parentheses because there's two terms separated by subtraction, equals, and let me move that a little bit, equals 3, I'm putting the number out in front, and then we have x plus 3, x minus 2. All right, cross multiplying is done. Check. Now, what's next? Simplify, right? Okay, I'm going to show you all a trick. Here's a trick. If you have matching terms on both sides, you can actually cross them out, because like we could divide by x minus 2 on both sides, and it would cause us to be able to cross out the x minus 2 on both sides. So instead of having to like go through the steps of always writing like the division and stuff, the trick is if you have matching terms, x minus 2 and x minus 2 on both sides, and they're separated by multiplication here, we can cross them out. So let's do that. X minus 2 get crossed out. And we are left with, let's write what we're left with. We have 3 equals 3x plus 3. All I did was make the x minus 2's go away. Because they're on both sides, separated by multiplication, I can cross them out. All right, now we need to solve for x. We need to isolate x. So the first step is to do the thing that's kind of furthest away from x, or not with the x. So what number is not really with the x? This 3. We got to get rid of that 3. We got to move it to the other side. Right now it's multiplying. So what operation am I going to use? Division. So we're going to do divided by 3, divided by 3. Also, y'all, time out. We have 3's on both sides. Up here, look. 3's on both sides. So what am I allowed to do? Cross them out. 3 can cross out. Now, what happens? What number do you think shows up here when we cross out everything? I'm going to give you a hint. It's not 0. It's 1. So we crossed out everything here. We get 1. And we're doing the same thing as like dividing by 3 on both sides, actually. And then this 3 just disappears on the right-hand side. So we get 1 equals x plus 3. Since there's nothing multiplying here, I don't need my parentheses anymore. All right, and then we do inverse operations to isolate x. Minus 3, negative 2 equals x. All right, we have solved for x. We are finished. All right, and I know that was kind of like trippy. We're going to practice some more in class together, and hopefully after doing some more practice, it'll make more sense why we were like crossing out things and stuff like that. All right, y'all, good work. Let's practice.